As we turn the corner to spring, with the sun a little higher in the sky each day, average temperatures across the Commonwealth are increasing at 2 to 3 degrees per week. So in general, atmospheric conditions are getting tougher to support snow. This time of year, even when the air aloft is still pretty cold, there's often a thin layer of above freezing air right down near the ground. And for snow to reach the ground in this case, the relative humidity of the lower atmosphere has to be well below 100%. That's because as snow falls into the warmer air, the flakes melt a little around the edges. And because of the low relative humidity, some of these drops evaporate, which cools the air and slows the melting. As far as how thick the above freezing layer can be, if it's more than about 1,200 feet, most if not all of the snow will melt before reaching the ground. If it's only about 1,000 feet thick, there's a 50-50 chance of snow getting to the surface. That goes up to 70% if the warm layer is only 600 to 700 feet thick, and up to 90% with just a 300-foot thick warm layer. As a general rule, snow rarely reaches the ground with surface temperatures above 40. On the flip side, it's never too cold to snow, but it's tough to get a heavy snow at extremely low temperatures because it doesn't take much water vapor to saturate really cold air, essentially to get clouds and precipitation. This dependence on temperature is wrapped up in what's called the Clausius-Clapeyron equation. We will do the math for you by converting this into a graph. Temperature is on the x-axis, while the y-axis is the amount of water vapor needed to saturate the air, basically to make a cloud in the air at that temperature. Notice that as temperature decreases, the amount of water vapor needed to saturate the air also decreases, but never quite gets to zero, even when the air is really cold. And as an example, imagine a volume of air the size of a typical room. Let's say 15 by 15 by 10 feet. That's more than 2,000 cubic feet. And assume that the air is pretty cold, say 0 degrees Fahrenheit. Now, to saturate the air in this volume, essentially to create a cloud in it, we would only have to evaporate enough water to fill about 3 of these little medicine cups. That's only about 80 grams to make a cloud in about 2,000 cubic feet of air. And that's why some of the coldest places on Earth average the least precipitation. For example, at the South Pole, the average annual high and low temperatures are minus 50 and minus 62 respectively, and average annual snowfall is only about an inch. In fact, much of the interior of Antarctica is just a cold desert, but what little precipitation falls doesn't melt, and that's why the ice there averages about 7,000 feet thick, with some of the ice at the bottom more than 500,000 years old. Indeed, the Antarctic ice sheet and Greenland's as well are actually time machines, storehouses of ancient ice. That's enduring evidence that it's never too cold to snow. Stay tuned. Our extended forecast is next.